In this video, I'm going to explain the application or the use of de Moivre's theorem in finding the roots of complex numbers and also in simplifying complex numbers that are raised to large powers. De Moivre's theorem, in short, says if you have a complex number in polar form, like what we have here, and you raise it to the power of n, and this n is a rational number, which means it can be a positive number, or it can be a negative number, or it can be a fraction. If you do that, your answer is what you have on the right hand side. In fact, we apply de Moivre's theorem if our complex number is in polar form. So if we're given a complex number that is in rectangular form and it is raised to a very large power, you can't use the FOIL method or this direct multiplication of the brackets. You can convert that polar number, that complex number from rectangular form to polar form, then you apply de Moivre's theorem. Let me show you using a few examples. For example, let us say we have, let me start by writing de Moivre's theorem itself. It says if you have r says theta raised to the power of n, the answer is just r to the power of n, this n theta. So you take your r, which is your modulus, you raise it to the power of n, and your argument theta, you multiply it by n. That's what you do. A good example, as I said, you can use it to find the root of a complex number. Let us say we have a complex number. We have a complex number z, which is equals to 2 cis 120 degrees. Now, and we want to find the square root of z. So the question is find the square root of z. We can apply de Moivre's theorem in this case. Now, the root of z is equal to the root of 2 cis 120 degrees. And we know that when you take the square root, it is the same as raising to the power of half. So this is like 2 cis 120 degrees to the power of 1 over 2. Applying de Moivre's theorem in this case, it means 2 to the power of half cis or 1 over 2 times 120 degrees. This is what you do, which is root of 2 cis half times 120, 60 degrees. So this is the square root of our complex number z. And we have resolved it using de Moivre's theorem. It doesn't matter what power it is. Even if we are looking for the fourth root, which is 1 over 4, n will be 1 over 4. You're looking for the fourth root or the fifth root, whatever it is. You can simply apply de Moivre's theorem and you get your answer. Straightforward. Let me use it to expand a power. Or let me do another example where the original question, we're looking for the root of, find the root of, they're saying find or evaluate, find the root of 4 minus 3i. This is 4 minus 3i. We can apply de Moivre's theorem here. In fact, we should apply de Moivre's theorem. The problem is that our complex number is in rectangular form. Let us convert it first to polar form, which means we have to find r. So the solution here, the solution. Convert the complex number into polar form, which means we have to find r. And we know that r is the root of 4 squared plus 3 squared, or minus 3 squared, if you want to. We get our r, which is 5. And then we look for theta, the argument. Our theta is arctan. We get theta ref to start with, the reference angle, arctan 3/4. We know this is B, theta ref is simply arctan B/A. We know this. So punch in our calculator, we get our reference angle theta. You don't have to use the negative sign. Just make sure, or just put positive numbers here for your A and your B. Don't worry about the negative sign. So this is the arctan. I'm going to get the answer in degrees. So arctan 3 divided by 4. Arctan 3 divided by 4. So my theta ref is 36.87 degrees. 36.870 degrees to 3 decimal places. But if I sketch the Argand diagram of this complex number, it is in the fourth quadrant. So I have here 4 is here and minus 3 is here. So this is in the fourth quadrant, and the angle 36 degrees, it is this angle, which means our argument, really, it is this whole angle here. This is our argument. This is our theta. This whole angle here, which means it is 360 minus 36.860. So our theta, therefore theta, the argument, is 360 degrees minus 36.870 degrees. This is very important that you understand that the angle that you get from your calculator is called a reference angle. It may not be the argument. The argument itself, you deduce it by going to your Argand diagram. This is called the Argand diagram, and measuring your angle from here, from the positive x-axis in an anti-clockwise direction, and this is your theta. This whole angle here is your theta, which means that in our case, it's actually a reflex angle. So we have 360 degrees minus 36.87. So our theta, or the argument, is 323.13. This is our argument, degrees. Now that we have our r and our theta, it means we can express our complex number in polar form. From here, we can say, therefore, the root of 4 minus 3i is equal to the root of r, which is 5. Since our angle is 323, so this is our angle, 323.13, 323.13 degrees. Okay. Now that we have our complex number in polar form, we can easily apply de Moivre's theorem. So this means 5 is 323.13 degrees to the power of 1/2. Application of de Moivre's theorem gives us root of 5, because 5 to the power half it actually means root of 5. It says half times the 323.13 degrees, which gives us root of 5. Since our angle now is 0.5 times our answer, which is 161.565 degrees. This is the root of our complex number. I'm leaving it in polar form, but even if they want it in rectangular form, I simply have to write it in rectangular form if I want to. If the question says find your answer in rectangular form, I just have to convert this to rectangular form. Let me show the conversion. I'm going to use a different color for that. I'm going to start by expanding this into root of 5 cos. This is what the CIS means. It means root of 5 cos 161.565 degrees, 565 degrees, plus root of 5 I sine 165 degrees. Now let me write it clearly. Okay, this means plus root of 5 I and the sine of 161.565 degrees. I just punch into my calculator to get the first part of this, which is root 5 times the cosine of 161.565 degrees. I get minus 2.121, so it's minus 2.121. Then I punch 5, so this is the root of 5 times root of 5 times the sine of 161.565 degrees. I get a positive, so this means plus 0.707 I. You do this if they say give us your answer in rectangular form. So for you to apply De Moivre's theorem, convert your complex number from rectangular form to polar form, apply De Moivre's theorem, get your root, and if you want to convert it back to rectangular form, you can do that. I'm not going to do an example where we are simplifying a higher power or a high power of, we're simplifying a high power of a complex number raised to a very large power. This is what I'm going to do now. Right. We are going to use the same approach. We convert it. So we're going to convert first to polar form. Let me write what I want to. I want to. So here we're simplifying. Complex numbers raised. We're simplifying complex numbers raised to large powers. Raised to large powers. Sometimes we don't have to apply De Moivre's theorem. We can just simply apply our knowledge of algebra. Let's say it's raised to the power of 2. That is quite straightforward. You just open two brackets and apply the FOIL method. But if you have something like root of 2 minus I, all this is raised to the power of 6. And you want to simplify this. The question is here, simplify. It is quite tricky to simplify this because otherwise you're going to have 6 brackets that you have to multiply out. That is quite tedious. You can apply De Moivre's theorem in this situation. So the first task is to convert our complex number from rectangular form to polar form. I'm just going to draw a sketch of my Argand diagram. The real part is positive, which means we're somewhere here, and the imaginary part is negative. So we are in the fourth quadrant. So we are here, and our theta, our argument is this. This is our theta. What we have here is our theta ref. Please always take note of that. our argument, we measure it in this fashion from here in an anti-clockwise direction up until here. All right, so let us find our r to start with. Let's say r. So r is equals to the square root of a squared, which is the root of 2 squared, plus minus 1 squared. Our r is root of 2 squared is 2 plus 1, so our r is root of 3. This is our r. We can put it in, we can leave it in as I said, like this, or we can convert it to 3 decimal places, but it's fine. This is our r, and we can now get our theta ref. The reference angle is arctan 1 over b over a, which is 1 over root of 2. So it's like arctan or root 2 over 2 if you want. So this is the arctan of 1 divided by root of 2. Yes, we get 35.264 degrees. This is 35.264 degrees. 264 degrees. But this is our theta ref. It is not the theta, the argument itself. We know that the argument itself is more than 270 degrees, but it is less than 360 degrees. So we're going to say 360 degrees minus the answer here, then we get our theta. All right, let me continue. We have now r. Our r is equal to root 3. This is our r. And our theta is 360 degrees minus theta ref, which is 360 degrees minus 35.264. 35.264 degrees. 360 degrees, I mean. Then we get our theta here. So 360 degrees minus 35.264. We get 324. Sorry. 324.736 degrees. 736 degrees. This is our theta, which means we can write our now write our complex number as, remember it was, I'm going to write it afresh. I'm going to write it afresh as, it is root 2. This means root 2 minus I. Let me write it this extreme left. We mean here that root 2 minus I raised to the power of 6. It is the same as root of 3, which is our R. CIS 324.736. 324.736. All of this raised to the power of 6. To the left hand side here, we have, this is the rectangular form, this is rectangular, and here we have polar form. We converted to polar form for one reason, so that we can apply de Moivre's theorem easily. Now from here, we know that applying de Moivre's theorem, this means R, which is root 3 to the power of the 6, and then CIS, let me use, it should be a small letter C. So this is root of 3 to the power of 6, then CIS 6, which is your n, the power, times 324.736 degrees. This is what you do. You just punch in your calculator, then you have your answer. So this means root of 3 raised to the power of 6, we get 27. So this part here is just 27. Then we take the 6 and multiply 3 to 4.736. 736. We get 1948.416 degrees. So this is our answer. If you want to convert it to a rectangular form, you can convert this to rectangular form if you want. You just know that this means 27 cos 1948.416 degrees, 416 degrees, plus 27 I, the sine of 1948.416 degrees. This is all you do. Just punch in your calculator to get the real part here. So it's 27 cos of 1948.416. We get minus 23.001. So just minus 23.001. If we round off to 3 decimal places, then we go to the other one. We changed from this sign to from the cos to the sine. We get plus, it's positive, so plus 14.141 I. That's it. This is how you apply De Moivre's theorem. I have explained how you apply it when you're looking for the roots of complex numbers, or if you are simplifying complex numbers raised to very large powers, like to the power of 6 or to the power of 7 or to the power of 8. This is what you do. Convert to polar form and apply De Moivre's theorem. It is a very straightforward issue. It is very, very straightforward. Nothing big here. Thank you for watching the video. If you have any questions or any comments, just write in the comment section below. I will respond. Otherwise, give a thumbs up to the video and subscribe to the channel. Thank you.